Okay, this is a problem where you might have to put a little bit more thought into it. It's still a fundamental counting principle problem, but it says how many six-digit numbers can be constructed if 0 cannot be the first digit and digits may be repeated. Well, that is a standard setup for a fundamental counting principle problem. You're choosing a six-digit number, so you're making 6 choices. 1, 2, 3, 4, 5. Let's just make the other one over here 6. It says that the first digit cannot be 0. Now keep in mind your digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there are 10 of them. If you count them, there are 10 digits, 0 to 9. But it says you can't use 0 for the first digit. So if you can't use 0 for the first digit, you're only choosing among 1 through 9. So for the first digit, you only have 9 choices. But digits may be repeated, so once you've chosen a number here, you can reuse it again. And once you get beyond the first digit, it can be anything, including a 0. So now you're back to being able to choose anything, and since the digits can be repeated, it doesn't count down. So you can use any of the 10 digits there, 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 and there. The only restriction is you can't use a 0 in the first position. If you multiply those numbers together, you would get 900,000. So there are 900,000 different six-digit numbers that you can create such that the first digit can't be a 0, but the digits may be repeated. Let's ask another related question. Using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the same as before, how many six-digit numbers can be constructed if the number must be odd, greater than 600,000, excuse me, and the digits may be repeated? So you've still got a six-digit number, so your setup will be the same as before. But you've got to look at all these extra conditions. The number must be odd. Well, whether a number is even or odd is controlled by the final digit, the ones place. So the odd digits are 1, 3, 5, 7, and 9. 1, 3, 5, 7, 9. That's 5 of them. So if the number has to be odd, it must end in one of those 5 odd digits. It's got to be greater than 600,000, so that means the first digit has got to either be a 6, 7, 8, or 9. If the first digit is a 5, that's not going to be big enough. If it's 4, 3, 2, 1, same thing. So the first digit, in order for the digit itself to be greater than 600,000, the first digit has to be at least 6. And there are 4 numbers, 4 digits, 6 or larger, 6, 7, 8, 9. So there are 4 possibilities there. Once you get beyond that, you satisfy the 2 restrictions, and it says the digits may be repeated, so you can use any of the 10 digits in the middle. In between is 10 because digits can be repeated, but it's not 10 here or on the front end or the back end because of the restrictions. This is because the number has to be odd and there are 5 odd digits. This is because the number has to be at least 600,000, and that would force you to choose a 6, 7, 8, or 9. Actually, greater than 600,000. But if it's going to be odd, it can't be exactly 600,000 here, so you don't have to worry about that part. So the answer is simply 4 times 10 times 10 times 10 times 10 times 10, and that comes out to be 200,000. So there are 200,000 different 6-digit numbers that satisfy those two restrictions.